Hello everyone, my name is NURIN Aqilah binti Jamaluddin and I will present to all of you on how to make your own FCC crystal.
So how to make it? Apparatus that you need to be prepared are some salt, hot water, glass, spoon and container. First of all, pour some hot water in a glass and insert a full spoon of salt. We need to use hot water so that the salt is easily dissolved. You can use cool water, but it will take some time to dissolve the salt. Salt is inserted until the solution becomes concentrated. Using the spoon, the solution is stirred to dissolve the salt. Next, the solution is poured into a container and let the solution evaporate until white cubic crystal form. We use a large surface area of container because it will increase the time taken for the solution to evaporate. What will you see? From picture shown on day 1, after few hours, water is evaporated but the crystal structure hardly to be recognized. White cubic crystal is formed on day 2 but there is some water left. After few days, we can see the clear structure shape and sharp edge of white cubic crystal. I put them on a black tin so the white cubic crystal can be seen more clearer as shown at the most right picture. One of the length crystal that I measure is around 0.3 cm.
What is FCC crystal actually? FCC stands for face center cubic. This crystal structure means that atoms are located at each of the corner and on the center of all the faces of cubic unit cell. Some examples of atoms that have FCC structures are copper, aluminium, silver and oro, which is gold. The three pictures below represent of the FCC unit cell. In the class, we have learned the characteristic of cubic lattice of FCC as shown in table right. FCC structure is highly efficient packing arrangements. FCC lattice is one of the closest packing arrangement in 3D spaces as it maximizes the packing efficiency by occupying 74% of the available space, which reduces the energy of the system. Salt known as sodium chloride is an ionic compound where naturally occurs as white cubic crystal. The white color of sodium chloride crystal is due to the way ions interact with light. Both sodium and chlorine ions are colorless and when they bond, they form a crystal structure that doesn't absorb visible light. Therefore, crystal appears white. Additionally, sodium chloride crystals are transparent to light, which also contribute to their white appearance when observed in bulk. Is salt have FCC crystal structure? The answer is yes, and we can see that at the picture below. Chlorine ion occupy the corner position and the center of the faces of the unit cell, while sodium ion occupy the octahedral voids between chlorine ions. Each sodium ion surrounded by 6 chlorine ions and vice versa, creating a 3D arrangement that gives sodium chloride its solid crystalline form. This structure allows for both ions to be switched since the coordination numbers are equivalent. FCC structure is highly stable for sodium chloride because of ionic bonding and efficient packing. In terms of ionic bonding, the strong electrostatic attraction between sodium ions and chlorine ion in the FCC arrangement contributes significantly to the stability. Next, in terms of efficient packing, as discussed before, we know that FCC is one of the most efficient packing arrangements. Thus, sodium chloride crystal structure, which is FCC, is highly symmetric and have stable structure. From the picture, we can see that sodium is a metal which tends to lose an electron, while chlorine is a non-metal which tends to gain an electron to achieve stable electron configuration respectively. As a result, sodium becomes positively charged ion while chlorine becomes negatively charged ion, and both ions are attracted to each other due to the electrostatic force between oppositely charged ions. Sodium ion and chlorine ion bond together to form sodium chloride, which is a stable ionic compound as mentioned before. When sodium chloride is dissolved in water, cubic crystal structure does not remain in the solution. The polar water molecules interact with sodium ion and chlorine ions in solid crystal. The positively charged hydrogen atom of water are attracted to the chlorine ion, which is negative charged, and oxygen atoms are attracted to the positive ion, which is sodium ions. These interactions are strong enough to break apart the ionic bond between sodium ion and chlorine ion, causing the crystal structure to dissolve. After dissolution, the sodium ion and chlorine ions are no longer arranged in the cubic structure. They are free-floating as individual ions in the water, surrounded by hydration shells of water molecules. Therefore, the cubic structure disappears in the dissolved state. When water begins to evaporate, the concentration of sodium ion and chlorine ion will increases, and they will begin to recombine and form sodium chloride again. During the recrystallization, the sodium ion and chlorine ion will reorganize into the same cubic crystal structure because of their regular ionic arrangement and the energetic preference for this geometry. So, while sodium chloride dissolves in water as individual ions, the cubic shape reappears when the solution is evaporated and crystallized. That's how the cubic shape forms. The picture below is the crystal I got by my own self. The crystal is beautiful, isn't it? So I hope viewers are willing to try to do your own crystal after watching my video. Thank you for listening.